Welcome back to part 2 of the Chapter 5 review. We did 7, 8, 9, and 10 in class, so this will just be me going through and redoing these problems. For questions 7 and 8, we are going to be using the double angle formulas, and it actually tells you what double angle formulas to use. For example, this one tells you to use sine 2x. So if you have your notes or if you kind of reference this sheet, the formula you're going to use is this 2 sine x cosine x to evaluate it. So what we really need to do is figure out what sine of this angle is, or what sine of x is, and what cosine of the angle is. And in order to do that, we need to solve for the last side using the Pythagorean theorem. It ends up being 5. It's a 3, 4, 5 triangle. Once you have that last side, I think it's helpful to figure out what sine of x is and what cosine of x is off to the side. Sine is opposite over hypotenuse, so 3/5. And cosine is adjacent over hypotenuse, 4/5. And then you just need to throw those fractions in for their equivalent parts. So 2 sine x is going to now become 2 times 3/5 times cosine x, and cosine is 4/5. Multiply it all together and math fractions so that you get a reduced fraction, and you're going to get 24 over 25. At this time, you can stop the video and try the problem on your own, or redo it on a separate sheet of paper, or move on to number 8, where we are going to use the double angle formulas in order to solve all the solutions for this equation. So this is actually a mix of the double angle formulas as well as the stuff that we did in section 5.3 where we're solving for the angle. The first thing that you need to do is use the identity in order to rewrite sine 2x as 2 sine x cosine x. If you look at the front part of the equation and the last part of the equation, you might notice that sine of x is in both parts, so what you can do is factor it out. If you take out a sine x from this first quantity, you're left with 2 cosine. If you take out a sine from this quantity, you're left with a placeholder of 1, and that's all equaling 0. Once it's factored, just like any other algebra problem, you can take each part and set it equal to 0. And this one I'm going to go ahead and subtract the 1 divided by 2. So this is going to be cosine x is equal to negative 1/2. And then what you'll need to do is look on the unit circle where sine is equal to 0. And that happens at 0 and pi. The other place is that we're going to, the other places that we're looking for are where cosine is equal to negative 1/2, and that's going to happen in quadrant 2 and 3, and our angles are 2 pi over 3 and 4 pi over 3. 2 pi over 3. And that should take care of part 8. At this point, you can stop the video and try it on your own. Number 9 and number 10 are both dealing with the half angle formulas. If you have your notes, you can flip to the half angle formula part of your notes. I also have the half angle formulas written right here. They ask us to evaluate sine of 105 using the half angle formula. And they tell us actually a little hint on what to use for our x value in the half angle formula. So if you kind of copy down, or if you reference this sheet, this is going to be the sine half angle formula. I'm picking sine because I'm doing sine of 105. I'm just going to copy down the formula. Instead of u, I'm going to use x. So this is going to be sine of x over 2 is equal to plus and minus the square root of 1 minus cosine x all over 2. They tell us that 105 is half of 210. So essentially what they're saying is that this is going to be what you plug in for x, because 210 divided by 2 is 105. So really doing 210, or sine of 210 divided by 2 is the same as doing sine at 105. So I'm going to add that in. If you change the x on this side, that's going to change the x on the inside of the equation. So this is 1 minus cosine 210 all over 2. At this point, you would need to go to your unit circle and then find out what cosine is at 210. And I think cosine at 210 is negative root 3 over 2. And we need to plug it into our equation. And that will take the whole place of all of the cosine values. So what I mean by that is that it's going to become 1 minus the quantity negative square root of 3 over 2. All over 2. A little simplifying, and you should be done with this. First off, the minus negative will become a plus. Second off, you have a double fraction, and I want you to get rid of the extra 2 on the inside of the fraction in the numerator. In order to do that, take every single part, you're going to multiply it by 2. Leaving you with, as I scroll over, with 2 minus the negative, right, so that'll turn plus, the square root of 3 all over 4. From here, the quick way to think about it, if you look at the 3 numbers on the inside of the radical, 4 is a perfect square, so you are able to evaluate the square root of 4. Since it's on the bottom of the fraction, when you evaluate it, so when you take the square root of 4, you need to keep the 2 on the bottom. That will be the solution to that. I would definitely try this one over again, just to get some practice with the simplifying and getting to the final answer without the double fraction and without 4 in the bottom. Good luck. The next question, I did have a little typo error. If you could change this so it's positive 3/7, reason being is that if your angle is between 3 pi over 2 and 2 pi, you're going to be in quadrant 4. And that's really going to actually give you a positive cosine value. So they told us a couple things. They told us that cosine is 3/7. They told us that cosine, or that they want us to find cosine at pi over 2. And by pi over 2, I'm sorry, they want us to find cosine at x over 2. I'm going to cover this up for a second and show you what the equation is for cosine at x over 2. It's going to be this general formula, but instead of the u, it'll be an x. So for us, you're going to take, or have plus and minus the square root of 1 plus cosine of x all over 2. If you're not quite sure where to go, I mean, there's nothing to be able to look up on the unit circle. We really need to use this information to help us. It says that cosine is 3/7, and what that means for this whole thing is that this cosine is going to be 3/7. So what you can do is rewrite the radical so that it is 1 plus 3/7 divided by 2. You can throw all of that into your calculator and reduce the fraction. I think you end up with 5/7 on the inside. So to finalize the answer, you can just leave it as plus and minus the square root of 5 over 7. And you can leave that as just one big radical. I'm fine with that. Again, replay some of these. Try the questions over again. You will be fine. Maybe cover up your answers and or try the problems on a separate sheet of paper. in order to prepare you for your test tomorrow. Good luck!